Alright, let's take a look at this problem. Write the equation for the line that passes through the points 2, 3, and -1, -5. Now, hopefully you notice that first thing is we've been talking about point and slope, yet that's not the information they gave us. They gave us a point and then another point. And so the question becomes, well, we call it point slope for a reason. We need a point and we need a slope, but we don't have the slope here. So what do? Well, the nice thing is we know how to find slope from a previous lesson. If you remember this equation, slope is equal to y2 minus y1 over x2 minus x1. So if I pick this one to be x1 and y1, and I pick this one to be x2 and y2, and then I can just plug these in and I'll have the slope. So then I can do point slope form. So let's see here, y2 is -5 minus y1, which is 3, x2 is -1, and x1 is 2. So I work that out, get -8 over -3, which negative and a negative is a positive, we get 8/3. So now we have a slope. So now the question becomes, well, what about a point? They actually gave us more than we need. Point slope form calls for 1 point, not 2. Well, the nice thing is you can use either one. And in fact, what I'm going to do is I'm going to do both. I am going to use this point to do the equation right here. I'm going to do y minus my y coordinate of 3 equals the slope times parentheses x minus the x coordinate of 2. And there's our equation in point slope form. Now, like I said though, it doesn't matter which point you use. So let's say somebody else you're working with decided to use this point. Well, they would do y minus -5 equals the slope, which is still 8/3, and we get x minus the x coordinate, which is -1. And so right now, you know, if you're working with a partner and trying this stuff out, you're noticing you have two different answers. Well, it turns out these are actually the same equation. It's just because we started out differently doesn't mean they're not the same. In fact, to prove it, what I'm going to do is I'm going to put these both in slope-intercept form so we can see it. If I do distributive property here, I get y minus 3, whoops, 3 equals 8/3 x minus 16/3, which would be 5 1/3. And if I add 3 to both sides, I get this equation, y equals 8/3 x minus 2 1/3. Now, let's take this one. This, if I clean it up, first off, minus a -5 would be y plus 5. If I distribute the 8/3, I get 8/3 x, and again, minus a negative is really plus, and then 8/3 times 1 is 8/3, or in fact, you know what I should do is 8/3 would be 2 2/3. Then I subtract 5 from both sides, and I get y equals 8/3 x. 2 2/3 minus 5 would be -2 1/3. So it does turn out it really doesn't matter. I can use either of the points, and I use my slope, and even though they start off differently in point slope form, when I rearrange them into slope-intercept form, I get the exact same identical equation.